Welcome to CognitionChunks. This is Beyond the Lines, Stepping into Non-Euclidean Geometry. Explaining Non-Euclidean Geometry. Note this is coming from a relative novice on this topic, who is trying to learn about this topic from GPT. I am not a mathematician or an expert on this topic. A follow-up series to distinct types of math branches. The origins, breaking away from Euclid. First, a bit of nostalgia. Remember good old Euclid? About 2,300 years ago, he had everyone convinced that his 5 postulates were the bedrock of geometry. Especially that infamous 5th postulate which assured us that parallel lines would never meet. It was a comforting, stable vision of the universe. But fast forward to the 19th century, and suddenly, the math world was buzzing with whispers, what if Euclid was wrong? Enter the mavericks, Janos Bolyai, Carl Friedrich Gauss, and Nikolai Lobachevsky. They dared to imagine a universe where geometry behaved in stranger ways than one might expect. The pillars of a new universe, axioms in non-Euclidean geometry. Our first stop on this cosmic journey is the sphere of hyperbolic geometry. Here, if you draw a line and pick a point not on it, something magical happens. You can sketch not 1, not 2, but an infinite number of lines through that point that never intersect with your original line. In this sphere, the interior angles of a triangle add up to less than 180 degrees. Oh, and speaking of triangles, the area of a hyperbolic triangle is actually proportional to the amount its angles fall short of 180 degrees. How's that for a mathematical marvel? Now, let's hyperjump to another corner of the geometric universe, elliptic geometry. You're in for a bit of a culture shock. Remember how we cherished parallel lines? Well, forget them, they don't exist here. Every pair of lines in elliptic geometry meets at 2 points, and the sum of the angles in a triangle is greater than 180 degrees. A landscape of mathematical wonders, notable examples. But wait, there's more. Inside these universes exist captivating landscapes. In hyperbolic geometry, you'll find the Poincaré disk model, a hypnotic realm where lines curve and twist in arcs. Tiling this realm with regular polygons offers visual ecstasy unlike anything in Euclidean land. Meanwhile, in elliptic geometry, the surface of a sphere serves as the playground. Geodesics, the curved lines here, weave around the sphere and eventually meet up, creating a tapestry of interconnected paths. The real world, practical applications. And just when you thought this was all a theoretical mind-bender, non-Euclidean geometry actually has some pretty real-world applications. Take Einstein's theory of general relativity. The Big E used the geometry of curved spaces to explain the gravity-mediated dance of planets and stars. Even our GPS devices secretly perform complex calculations that account for the curved geometry of spacetime. And let's not forget computer graphics, where hyperbolic geometry helps in rendering realistic images. Down the rabbit hole, philosophical quandaries. Lastly, this geometrical roller coaster offers more than just mathematical thrills, it shakes the very foundation of our philosophical understandings. If multiple geometries can exist, each consistent within its own framework, what does that say about the nature of truth? Are mathematical objects independent entities that exist out there, or are they constructs of the human mind? Non-Euclidean geometry has nudged us to question the reliability of empirical evidence and to ponder on the limitations of formal systems. So, in wrapping up this voyage, what can we glean? Non-Euclidean geometry, you see, is more than just an abstract offshoot of mathematical theory. It's a testament to the limitless capability of human thought, a beacon that guides physicists in understanding the universe, and a cornerstone that has forever altered the philosophical debates on truth, reality, and the fabric of understanding itself. If you're leaning in with your eyes wide open, eager to ponder, debate, and explore further, then this cosmic journey through non-Euclidean geometry has achieved its purpose. And that, dear listener, is just the tip of a non-Euclidean iceberg. This has been another Cognition Chunks. Was this accurate? Did GPT just make up a bunch of stuff that does not exist or does not make sense? Find out next time in the Cognition Chunks follow-up.